Okay, so I apologize if I'm a bit nervous. I will try to make it fluently. So I'm Etienne Carriere from ST Microelectronics. I work as an assignee in the Linaro Security Working Group, and mainly on the OPTI component. So this talk is about secure case services inside the OPTI and this Linaro initiative to provide such services that is currently not available but a request by a lot of people, let's say. So let's just have a short round of what. Well, I apologize. I will. There must be some better way to.
Can't you go full screen now?
Oh no, if I go left, right, it's okay. So just a quick overview of what we've called secure case services, because there's no real generic name for such services. A short introduction about what is OPTI, but maybe everybody here knows what is the OPTI, but just a few slides about it. And then, the work we did in the OPTI to provide such secure case services, the few issues we've initially faced, what has been implemented so far, and what's planned for the next short and long term. So, secure case services, mainly talking about secure case services, there is several solutions to provide secure case services. Maybe you know some of them, which are mainly dedicated hardware to have some secure secrets stored somewhere, and that are very hard to tamper with. The most well-known hardwares are some HSMs, these hardware security modules, or the secure elements. Mainly the global platform initiative about it. There are those trusted platform modules, which are dedicated hardware. This is a nice picture of this kind of device. And also there are trusted execution environment, which could be helpful to provide such secure services. And we're more interested specifically in this case, in secure case. So secure case, I call that secure case services. Sometimes it's referred to as a secure case store or case stores. And it's about having some secrets in some hidden environment. And one can use these secrets to perform some operations. And the system should ensure that the secrets cannot be tampered, and also the use of the secrets cannot be tampered. It's like you have some secret key, you don't want the secret key to be exposed or modified, and when you run some cryptographic operation with such keys, you don't want the operation also to be tampered, so that you can really rely on the results. So with the secure keys, usually what we need to do with secure keys is, to what we call import secure keys, which is usually what we refer to as some provisioning, means to have some initial secrets being loaded in the secure device or entity or environment. So, provisioning keys, generating keys from pre-provisioned keys, or simply running some cryptographic algorithm on some data using some previously provisioned keys. Usually the operation we need to do is some ciphering, which is some encryption, decryption, or computing a signature or verifying some signature, or some mix of that. And there's a whole bunch of cryptographic algorithms that are well known, well defined, and quite reliable. So this, and with these secure keys, to be sure that the secure keys cannot be used for bad purposes, the keys will have usage constraints, a lot of constraints, and a constraint could be, for example, that one to be able to use such a key may have to authenticate itself before being able to use the key. and maybe other services like extracting a key that is in the secure storage, maybe for debug means, or maybe that you have derived a secret from a very secret secret, and the derived secret is not that secret, and you can extract the secret from the secure environment so that it's used in a less secure environment, but the secret does not expose the real secrets you want to protect and that will remain in the secure environment. So, well, it's such services that, if I go one slide back, if you want to buy an HSM or a smart card reader or a TPM and plug that into your device, it's a very nice solution, and it's quite bulletproof, I guess, but it costs quite a lot. And in this Linaro, we have this trusted execution environment, which is open source and which is so provided to anyone. And what we were wondering is how could we provide such services benefiting from the Opti execution environment. Well, we know what services we need to provide. Sadly, there is no unique API or unique interface that is shared by everybody to provide such services. So we know which algorithm or which crypto algorithm we would like to exercise, but we must find the right interface so that people can rely on, and we don't want to define a new interface or a new specification for such services. So we were to find the right interface one could use for that. So let's a bit talk about Opti. Are there people that don't know anything about the Opti here? Okay. Oh, maybe Joachim. So just for Joachim, I won't talk much about Opti. I guess there are a lot of things we should say. For what concerns us here is, this is the usual drawing we have with Opti, is that Opti is built on the global platform T specifications that defines two API. What is the API for a client to connect to a trusted application to get some secure service between being executed. And global platform also specifies the API a trusted application can rely on, so that it does not have to build all the services, but it at least only have to implement what is of its own interest and or his own sequences, relying on standard services like cryptographic algorithm, which are implemented in a standard way and accessible through a unique API. So that's the Opti. Okay. So from a client side, basically with the Opti, a client can open a session towards a trusted application, can invoke services providing a command ID which defines which service is expected from the trusted application. And with this command ID, global platform specifies that we can pass only up to 4 parameters for one services, knowing that a parameter could be a numerical value or could be a buffer. But that means that when you, with the global platform, you have these constraints that if you want to provide data in buffers, oh, just a note about these slides, they will be available in the Linaro Connect. If one wants to get the slides before that, just send me a mail, I will send you the PDF. Okay? So it's freely available, so do not hesitate. So if you have to provide a lot of data for your services, a global platform specifies that you can only provide like at most 4 memory buffers and no more. So it's a restriction we have to deal with. So usually you open a session, you invoke your command with some parameters, and when you're done, you close the session. That's the client API defined by the global platform and followed by the Opti. And from the trusted applications, there's a whole set of API which are defined by this specification, which is called the global platform T internal core API. I did not list all of them. I just listed here few of them which we'll be interested in about secure keys. is that some secure storage functions that allows to have some secrets being written in a persistent matter in a secure storage. And also this API provides all the standard cryptographic schemes and a well-defined API to exercise them. I won't list them. Okay, so we know the service we want to do, and we're in the scope of the OPT. So now, how can we provide a client such services? Our goal is, with the OPT, we would like to provide all the secure parts, and leaving up to the client to be able, from some interface, to exercise such services. So, who's interested in that? Well, it could be a userland applications, as written here. So we need an API that is not already provided by the global platform. So we must find the right API for such client. But maybe Linux kernel on service would like also to benefit from such service, or maybe some non-secure bootloader stage that would need to access such secure keys, or this here, trusted application, or maybe an hypervisor that runs in the non-secure world and that will need to access such services. For this presentation and the works done so far, we've limited ourselves currently to a client application, means for client, user and client application to exercise the service that is implemented in the secure world. And also something to note here is that the service we intend to provide will be implemented as a trusted application, not as a core, OPT core services, since the OPT can be there to serve several things and several applications, and if we have some bugs in our services, we don't want our service to expose all the secure system. So isolating these services in a trusted application is a way of preventing flaws in that to corrupt the whole secure stack. Okay, but hopefully we'll not put back in our trusted application. So I will skip this one. If few words in case we would like some Linux kernel to be able to exercise that, or some bootloader. Well, ourselves, we restrict at the first step of userland clients. So for userland clients, which API should we provide to the clients? We don't want to build a new API, and I guess we will hardly be able to provide or to design a new API that is very mature or to take time. There are some that exist. There's no unique we could rely on. I've listed few that existed, like this trusted platform module, which has an API, but not all the service we expect. And the two mains we have looked at is the Android key store, which has a well-defined and very rich API for such secure key services, and this PKCS11 specifications that defines an API for a client to exercise such service, which is a bit less rich than the Android key store, but has an advantage on the Android key store is that if you don't want to have an Android in your non-secure world because you have some other distribution that is not Android, well, the Android key store is so rich that you need to implement some of the Android support. So for this very task and initiative, we decided to provide this as following the PKCS11 rather than the Android. And there is another initiative that will be starting at the security working group to look at how to provide such equivalent services, but based on the Android key store for Android-specific environments. So just another word, if you have questions, do not hesitate to interrupt me. Okay, I try to be fast because time slips so quick. I will skip this one. It was, well, there are a lot of common things between PKCS11 and Android key store, but as I said, we don't want to get all the Android to force people to use the Android. So this is about more the PKCS 11. So what did we do with the PKCS 11? This initiative, which is not already merged in the OPTI, it's still ongoing work. We are still discussing on how to implement that, how to merge that, and how to define all the APIs and starting the implementation. But the goal is to provide the library that is based on the PKCS 11 specification for clients, and plugging this API on top of the native OPTI client API, so that a client can reach the service and it goes straight to this SKS secure case store or secure case services, whatever, trusted application. And we will implement the trusted applications that will implement the services, and also provide some test means to be sure that what we have implemented is functional and does not have flaws. So this is the scope of what we want to provide. So, and first we'll start from a very basic work base to have all the frameworks and the basics be there, and then later on we'll add more cryptographic supports, maybe other interface for kernel bootloaders or whatever, and eventually extend attributes, and maybe a word about all conversions that can be done between the PKC11 supports and the Android K-store supports. And of course, once we have something that is clean enough so that anyone can have a reliable, can start with a reliable work base, well, contribution will be highly welcome, as in other projects, I guess. We're in an open source, of course. So PKCS 11, here is the link for the specification. Basically, the specification defines all the functions a client can invoke, and all the arguments that are expected from these functions, which are called the ABI. And the specifications also defines in two other documents all what they call mechanism, which are the cryptographic algorithms that can be used, and which parameters they expect, and what is the structures that should be provided to feed the cryptographic sequence with the right settings, so that it executes what we expect. And there's two documents for that, because there's a historical legacy algorithms, which are almost now not that used, and all the main algorithm like AES, DES3, or RSA, elliptic curves are in this current mechanism specification. And also the PKCS 11 provides some C++ header files, which defines all the prototypes for the functions, all the IDs that allow us to identify the mechanisms, to identify the key attributes, and mechanism attributes, and well, and the parameters for the functions. So we have all the basics for the layer for a client to be able to exercise the services. So since we're in the OPTI, and the OPTI is based on global platform specification, and when you exercise service through the global platform specification, you must send a command with some parameters. So for each of the functions defined by the PKCS 11, we just define a command, and all the parameters that were expected from the PKCS 11 function, we have to wrap that, or in the global platform API with the global platform API constraints as parameters or arguments, which will be provided by each command. And since we have only 4 parameters, we'll have to, in some way, make sure that all these parameters, if the PKCS 11 specifies them as pointers, several pointers to several places in memory, we have to put that only in up to 4 buffers. So we cannot use straight the PKCS 11 API inside the trusted application. We at least need to reformat things. but our intent is that the trusted application interface really reflects what is defined by the PKCS 11. We don't want to define another API. Yeah, sorry.
The PKCS 11 interface is on the left, right? So that's specifying the C-create object interface?
I will have a slide later that explains what is the...
Sorry, we can switch mics.
So, yeah, it's my fault. It's turned on.
Okay, sorry. Well, I'll show in a slide what is the secrets that will be provisioned and how they're formatted. Here is some examples of such functions that are defined by the PKCS 11, and just highlighting that for each function we did just define a command.
Yeah, my question was really, it looks like the PKCS 11 interface says create object, but the trusted firmware command seems to be import object, which implies that it's not created locally within the trusted execution environment. That was my only question. Is that just a
create
example?
Object is the API, is the PKCS API for importing a raw, clear text object into the secure device. So clearly it's those kind of API you should exercise at some provisioning steps when you have clear things you want to initially provision. So it's an API that is proposed by the PKCS 11. Whether you want to use it for your provisioning or whether you want to use some other means for provisioning, it's up to the client, okay? So PKCS 11, so it's a whole set of functions, and of course, we're dealing with keys. Well, what we call secure objects. And actually, an object is a collection of attributes. And we also see this kind of principles even in the Android key store. It's like attributes allow us to identify what is the secret. So there are two main attributes, like a class and a typing class. For example, if we have an AES key, the class would be it's secret key, but well, it's a symmetric key, and the typing class would be AES key. Okay, and these are simply attributes of the key. Another attribute is the value of the key itself. Okay, it's an attribute of the key, and there are a lot of other attributes that will help the client to identify or to know which key he wants to use, and also a lot of attributes that will define all the constraints for the key and how it should be used, and well, restricting on this specific usage for the key, and if one wants to use the key for another sequence or another function, then the secure part should just refuse and not use the key. So here I just listed few of those kind of attributes, and knowing that attributes are identified. This is the PKCS specification, where an attribute, well, a key is a collection of attributes. So from PKCS point of view, you define a key as a number of attributes and a pointer to a piece of memory where you have all the attributes that are listed, and each attribute is being defined by its identifier, whether it's class, typing class, is it like some Boolean attribute like the object should be persistent or not. So you have the ID of the attributes, the size of the attribute value, and then a pointer to the effective attribute value. So we can have attributes that are themselves a reference to another series of attributes. And so because of the global platform constraints, we have to serialize that in some way so that it fits in less than 4 buffers, or it's easier to fit that in a single buffer, so that when, for example, you create a key, then one of the parameters of the C create object function will be the buffer that will define all the key's attributes. Okay, so we had to we reuse the PKCS specification, but we have to reformat the way data are presented. That's for the secret. So a secret is a series of attributes. And we have also cryptographic algorithms, which are called mechanisms in the PKCS 11. And a mechanism, or cryptographic algorithm, is identified by an ID, which is an identification number like AES CBC, for example. Here is one. So for an AES CBC, let's say that's first. So a mechanism is identified by an ID. A mechanism is also related to some parameters that will be needed to exercise the cryptographic sequence. And also an algorithm can be able to perform some processing modes of function. For example, encryption, signature, or derivation. Like if we take an AES CBC, if we want to make some AES CBC ciphering, then we should use the right identifier, so that we want to do some AES CBC. This will require one parameter, which is an initialization vector. And what we can do with this mechanism is only to make some encryption and decryption, because AES CBC is done for encryption and decryption. Okay. I won't go too far on that. For if one wants to make a key derivation using an AES CBC scheme, okay, the PKCS11 will define another mechanism that will be like derivation using AES CBC, which will not be the same as the AES CBC. AES CBC is made for encrypting or decrypting data. Okay. Derivation using AES CBC will be the mechanism used to create a key by derivation using AES CBC cryptographic algorithm. So the PKCS11 defines a long series of mechanisms, and each mechanism is really dedicated for a specific purpose. And mainly, okay, so this is just a slide explaining that, well, PKCS11 defines the mechanism by a series of structures that points maybe to some other structures, that point to some other structures, and to be able to fill that into, well, I'm late, into the trusted application. Also, we have to serialize that in some way, because we have this global platform constraints on the parameters when we invoke a service. Well, what can we do with PKCS11? Basically, we can inject a secret. We can create a secret from an already injected or an already provisioned secret, or we can use a provisioned secret to process data. So this three kind of family of processing we can do. So when we call such service like make a key derivation, or initialize an encryption, or generate a key, what we'll have to do in our trusted application is, well, initially just check that the parameters are same, okay? We must check that the function that is called is sane also, is eligible, it's identified. And then if the expected service is to create a key, then we must prepare the attribute list of the created key and make sure that it's sane. If we create a key, then we must check that the attributes of the created key matches the current state of the trusted application, or what we call the session state. That the created key is fine against what we want to do as a function. And in the process, if we need to use an already provisioned key, we'll also have to check that the provisioned key is allowed to be used in the current session state, and that the provisioned key is allows to perform the function. Like if the function is like derive, let's say, well, derive a key using AES CBC, and that the key we want to use that for is let's say an RSA public key, then, well, we ask a function for a key that was not designed for, so this is where you should reject the thing. This is all defined by the PKCS11, and what we need is to implement that. So basically, for each function, we'll go through this list of things to do, and well, it depends. If it's only processing data, then we don't create a key, so there's no point in checking what's the key created, because it's not created. But we use an already provisioned key, so at least we'll have to check that the key used is allowed to be used for the purpose it's used. Then once this is checked, we just process the cryptographic algorithm, for which we'll call the global platform API that will do the services. And then if everything goes well, we return the status. So that's what we have to implement in the trusted application. So, current status. Well, current status is that we have a first of kind, which is not mature enough. Okay, it's not even merged into the OPTI, so it needs to be reviewed. There are a lot of discussions on which should be the API for the trusted applications, so that we really reflect the PKCS specification, and that it's still flexible. But we want to start from an API, and we don't want to change this API later on. So quite a lot of discussion on that. And also we implemented a very limited set of cryptographic algorithms as of today, like some AES flavors of cryptography, some Mac things. I don't think, no, we don't have yet some K derivation support. There are some functions from the PKCS 11, for example, to read some key attributes or even to extract some key. We did not implement that, so we have to do that. And we have a test environment, but it's still weak because it's really at the early stage of this development cycle. And what we plan for the short term, well, first, have a real test framework. So testing what we implement is really, really important. Second bullet, I think we can just scratch it now because OPTI 3.1 will come soon, and I'm pretty sure that the current SKS stuff will not be mature enough to be merged in, so it will not reach the 3.1.0 for sure. Well, once we have something that is nice enough and gets merged, contribution, of course, will be welcome. And also, the main steps. Well, as part of the main steps, what we will do, PKCS 11 defines some support based on certificates. And in the OPTI and global platform, does not specify a lot about certificates. So we have to really investigate what we really need to support from PKCS regarding certificate and how to implement that. Well, I list several things which could be interesting, like if you want to provision something, we have this discussion about provisioning, and you need a first provisioning at some stage, and there are a lot of devices where the provisioning is quite well defined based on some like OTP fuses. So, and our SKS and the global platform define the secure storage, which is not based on OTP fuses. So we must find a way maybe to create or to provision secrets into the trusted application secure storage based on OTP fuses that will be read by the platform, which is a service that is quite platform dependent, but we believe we can provide some mechanisms that is generic enough for a platform to just adapt to its own OTP fuses access. Another really cool thing we would like to is if you have some secrets that are quite secrets and you're okay to hide them in the OPTI and under the trust zone, that's fine, but maybe you have even more secrets and you don't think the OPTI is safe enough to store them. Maybe you really want to rely on some, don't know, TPM, some HSM, some secure element as a smart card. Then how can we use this interface to have the same services but have some key processed in the trust zone, in the OPTI, and maybe some services that are delegated by the OPTI into the secure, more secure element, which is external. And I believe we could reach that using the PKCS 11 specifications, sticking to the same specification defined by PKCS, which can be extended. The PKCS 11 allows to extend the key attributes, so it could be a way to define that a key is not in the trust zone, but the key is even in a deeper, more secret entity. And of course, since there's also pressure for a non-Android solution and an Android solution, we really look at the convergence between both and how we can reuse all the work that is done, because what's the main difference between the Android key store and PKCS 11 is 100 key store defines a lot of other attributes that are not defined by the PKCS11, but there are a lot of same thing, like the crypto algorithms are the same. The main attributes, like a key is dedicated for AES, for decryption, or only for some authentication encryption, or those. We found both in the 100 key store and in PKCS11, so there can be a lot of convergence between both solutions. Not sure if the same trusted application could exercise both, but it could be a solution. So we'll see. We'll also look at that. And there are some reference find about a new version of the PKCS11. So if there's a new version that comes, maybe we should move to it. And well, that's an interesting setup. We'd like to exercise this file system encryption based on this setup. But for this file encryption system, then maybe, well, we'll need not this interface at user level, but it's likely that we need this interface or this kind of interface in kernel level or in some non-secure bootloader. So this is things that should be implemented and proposed. Okay. And of course, there are a lot of other things we would like to do. And among this, which is quite important, and we had this discussion, let's spend quite a lot of time, is clarifying and provide guidelines about how to provision secrets using this, this framework. And I won't go in the other bullets because I'm already out of time, and maybe you have a few questions, or maybe you're hungry. Yeah, sure.
Regarding cryptographic algorithm implementation, do you do it from scratch, or you base yourself on existing libraries
okay.
like embed TLS or TinyCrypt?
Yeah, I understand. Question is, for the cryptographic algorithm, let's go back to a nice picture just to illustrate and that be sure we all talk about the same thing. Here, we'll have to do some cryptographic algorithm. Question is, do we implement them from scratch? Shall we use an existing library or some means? Well, for this, we have the global platforms that specify APIs which allows us to exercise those cryptographic algorithms. So actually, with the OPTI, the privilege layer is designed to provide this cryptographic algorithm, and the global platform allows us to have a standard API for a trusted application to ask for such a cryptographic sequence to be executed. So what we plan to do is to rely on the global platform API. And then it's up to the OPTI to decide which mean we'll use to implement the cryptographic algorithm. Currently, OPTI is based on the Lipton crypt, so it's a Lipton crypt namely that is used for the cryptographic algorithms. But there are other, well, there are some algorithms where we don't use the Lipton crypt, but maybe, well, we use other sequence because we want to benefit from some hardware things. There is also another initiative that would like to provide the embed TLS library in the OPTI. So, but that's not the business of the trusted application. Okay, because the trusted application, hard trusted application, will rely on the OPTI for such service. As for secure storage, it's not the trusted applications that will do what needs to be done for secure storage. It will rely on the OPTI, and it relies on these well-defined APIs from global platform that allows any trusted application to have some persistent storage being accessed.
So where did the requirement come from, or the interest in this? Like, were there specific kind of market needs? I'm just wondering, curious about the requirements, like, you know, what pushed you to do this? Okay,
question is, which requirement push us to such kind of implementation and work? Well, two main, well, we need, let's say, there are devices where we have very secrets, and where the solution is not to use the trust zone because the end manufacturer is not confident enough in a trust zone, so he will use a TPM, a smart card, or whatever. But there are devices where the secret is quite secret, but it's not that secret, so that the cost of a TPM or an external device that is very secure is worth. So this is where someone would like to use the trust zone for such secrets. that are not that secret so that you spend that amount of money. There were, just before that, there were a session by Mark Brown on the IoT where he talked also about all several solutions that can be done to provide such services, and each solution is a cost. And as he said, well, for this solution you have to balance between the cost of the solution and how your secret is worth compared to the cost of the solution. That's for main thing I will just answer. And maybe another part of the question would be, why PKCS 11? Why Android key store? Or maybe it's out of scope of your question?
Yeah, I wasn't PKCS per se. I was interested in, like, what the kind of market requirements were for, secure key storage, because there is Android key store exists.
Excuse me, I just give you the microphone because I won't be able to repeat all your questions.
There is an Android key store for Android devices, and so
Yeah.
I was just curious, like, where. So for mobile, it seems like there's already a solution, right? And for Android mobile, and so where was the interest coming from in the market for another solution?
Okay, definitely, if you have an Android OS, then you should use the Android API. And if you don't have an Android OS, maybe we could reuse the Android API. But from what we saw, the Android API is very rich, and to benefit from it, you have to take a lot of the Android frameworks and integration. And PKCS 11 is far more light and is standardized, is well known, so it's a more lighter API a client can rely on. And there are also people that has specifically for PKCS 11. So what's been decided in the Linaro Security Working Group, and I don't talk on behalf of Joachim, so we have to contradict me or to agree, but what was decided that we'll explore both streams. And at most we'll try to really explore both streams in a parallel, but in a converged way, so that what's done in one can be reused in the other, and so that we just share our code, especially since in the same group. And it would be a shame that we would work separately. Yeah, can you just pick up the microphone, sorry.
Do you have a specific platform, a specific hardware platform that we should, go and buy if we wanted to test this stuff out, or is it platform agnostic at this point?
Okay. As far as for the initial steps, because, well, just before I talked about using keys that would be in some TPMs or using keys that would be in smart cards, and to exercise that, you need a TPM or a smart card or whatever. But for these initial steps, that's pure software. It's pure software in a trusted application. It's pure software in the userland. So I would say any platform that supports Opti will support the thing. And what we want to do is to have something that is really platform agnostic. And if someone was just to have a look at it and just to test it, the easiest way is even to use a QEMU, because you don't need a platform, and it works well. And we rely on Opti for the very tricky part. The trusted application is really dedicated to following the PKCS, for this work, the PKCS specification and which attribute, how to implement this so that each attribute is really implemented how it should be. Maybe it's not the right sentence, but I guess you catch the idea. So that answers to your questions? Okay.
So on the topic of what platform you can use, I just wanted to follow up because I'm doing a lot of work with ARM in upstreaming their virtual platforms, which model their trust zone controller and do multi-core clusters, both in their infrastructure world, and there's going to be others coming as well, which will support a more mobile flavor. So they are under license, but the licenses are free. So once that work goes upstream, which should hopefully be in the not too distant, like in the next couple months or so, the infrastructure work is already upstream, but obviously you don't use Opti for the kind of UEFI-based stuff. So keep an eye on it. If you want a virtual platform that you want to be able to model the trust zone controller and partition memory and do all that stuff in a representative way, then you can just pick up on the software models and do that.
I was thinking.
But what we'll be providing is very pure software, and even the QM you will be sufficient just to exercise the thing. Right.
As you were talking about potential hardware acceleration, I was thinking, well, is there a board that's more advanced that we could?
Okay,
you know?
so that's Opti job. That's not the TA job. So if you have a platform that have some accelerating means, I guess you want such acceleration not only for the secure case services trusted application, but for any cryptographic that is expected from the trust zone. So that's Opti job. That's not the trusted application job. The trusted application, sorry again, relies on this global platform APIs that tells, well, you want to do some AES ciphering, just call the right API with the right parameters, and you'll get Opti to do the job. So that the trusted application does not have to deal with cryptographic and implement some things it does not. It's not designed to.
So just a quick addition on what Neriman has already pointed out. There are base models which are already available, and where you can do all the modeling, you can do the trust zone modeling, and it's basically V8A platform where you can run all of these kind of things already. So it's there. You probably don't have to wait for what Neriman was pointing out.
Again, I would say pick up a platform that supports Opti. Pick up the code for the threads, for the tests, for the client library, for the trusted application, it will work. Whatever is the platform, and if you have a platform that does not support Opti, start porting Opti on top of it, and then just use this Opti in a native way.
Are you going to integrate with OpenSSL?
We will integrate this with OpenSSL. This is more, well, it's another secure case services that is not defined by the PKCS 11. So it's a really interesting services, but you have, in such case, that your trusted application handles quite a lot about the SSL and the network connections. So there are some means for that, but currently it's outside of the scope of this, those kind of services. Because those kind of services for this initiative is really based on the PKCS 11.
Right, I guess so there's a PKCS 11 interface to OpenSSL.
Could you just pick the mic? Sorry.
There's a PKCS 11 interface that OpenSSL has, so it can use PKCS 11 based hardware, tokens, etc. I'm just wondering if you are gonna, if that's something you would. I mean, it should work, you know, for storing.
Oh, okay, understand. You mean you have some OpenSSL here?
Yeah.
That should rely on PKCS 11?
Yeah. Right.
Well, just plug this PKCS 11 library into OpenSSL. There are some components that is that, and if we did our job well, it will work.
I was wondering, yeah, so it's not something you're specifically gonna try out as far as your integration work goes?
I guess will be, because mainly using OpenSSL, I guess we can enhance the scope of the tests. So
yeah.
It will be a nice mean to have broader tests than the one we have as of today. So definitely, and it was one also a reason, maybe I should go back to this place. I just listed the 3 of them, but in the, well, looking in the internet, there are a lot of components that use PKCS 11 only for the cryptographic part. So any of those elements that rely on PKCS 11, then they can rely on our library, because our library aims at being PKCS 11 compliant. Well, our problem is maybe PKCS 11 has a whole bunch of cryptographic and supports, and for sure there are some we will not implement. Now, when I presented the PKCS specification, which is, sorry, I found it back here, we have those cryptographic algorithms that are defined by PKCS 11, and among them there are a whole list of algorithms that I think are considered deprecated as of today. We will have no plan to spend time on providing this to our PKCS 11. Here I put the example of the DES. Does one want to exercise DES? I won't spend time, even if maybe it's easy, because I think DES is already supported by the Opti through the Global Platform API. So it would be quite easy to support DES. It's like a few lines in the client API, few lines in the trusted application, and it should be done. But myself, I won't spend time for this. And if someone needs that, well, if we have a clean workbase to add some algorithm, then one can just do the job of adding those few lines so that this algorithm can be supported. Again, we don't plan to implement cryptographic in the trusted application. Cryptographic will be dealt in the Opti native part.
Is there a push to integrate OpenSSL into this whole framework? Is there a business case or push from someone?
Well, if you want to store your private key, if you want to initiate SSH connections and you want to have your private key stored in a secure world, that would be kind of the case for doing it, where you don't want to.
It's not just storing the key, because you have to do all the operations there in the secure world.
Okay, sorry guys. Yes, interesting the discussion, and it can go on and on. I mean, we're still here until tomorrow evening, so if you want to discuss yourself, no problem. If you want to ask questions, do not hesitate. My mail is here. If you want to get the slides, either you wait for Linaro to put them on the server, which should be done like maybe next week. If you want the slides before, just send me a mail. I will send you the PDF, no problem. Okay. Well, thanks to you. Thanks for your attention, and bon appétit.